Good morning, children. Welcome to our next class. In last class, you learned about electric circuits and the symbols of electric circuit. This all you learned. And today's class, we'll see how the switch is helping in an electric circuit and how to make your own homemade switch. This all just we discussed a little in last class. Once again, we'll see how to make a switch and how it is helping in an electric circuit. We'll see. To make this artificial or homemade switch, you need two uh, pin boards or jam boards. Jam pins. Will call these pins. So two jam pins and a safety pin. Both you connect with the wires and the cell and bulb in an electric circuit. So whenever the safety pin is connecting these two jump pins and the circuit is closed, nowhere open the circuit. So whenever the circuit is open, that means the switch is in on position. So whenever the switch is in on position, the circuit is set to be closed circuit. Whenever the circuit is closed, the bulb glows. In the same way, if you remove the connection between these two pins, that means the safety pin is not in connection with jump pin, then the circuit is opened. So when the circuit is open, bulb will not glow. So when the circuit is said to be open, that means the switch is in off position. So in this way, the switch is helping in an electric circuit. Understood, children? So in the you are also going to use this circuit to find out whether the given object is an conductor or an insulator. To find out the conductors and insulators are also used by these two circuits. That I'll explain you. Before knowing the conductors and insulators, we will also see the inner structure of electric torch, how the electric torch is working and what are the different parts present in an electric torch we are going to understand. And this electric switch is off position, on position, and how the circuit at which position the bulb glows. So based on this, in your textbook there are different circuits are given. So find out that each circuit closely you observe and find out in which circuit the bulb glows. In which circuit the bulb will not glow. If it is not glowing, what's the reason? Whether if you say yes, the bulb glows, what's the reason? So nearly 6 pictures are given in your textbook. Closely observe each picture and right below the picture, is that circuit an open circuit or the closed circuit? Whether the bulb glows or not. This is the activity you are supposed to do to understand about electric circuits. Okay, children? Now we will see the structure of an electric torch. So you know that every electric torch is having a bulb inside, a bulb. It has a bulb. So first we will try to understand the structure of a bulb. So inside the bulb, a tungsten. Inside the bulb, tungsten wire is present. So this tungsten is known as filament. So every bulb is having filament. When this electric current flows through this filament, the filament becomes hot and it releases the light. It gets heated up and releases the light. And also a bulb will have two terminals, positive and the negative terminal it has, a filament it has, and all this arranged in a glass which gives or reflects the light. So this light is helping, like this glass is helping like a reflector. So in the bulb, tungsten is present, acting as a filament, and the bulb has two terminals, and the whole structure is arranged inside, and before the bulb it has a reflector and a lens are present, which helps to reflect the light and to give the light. Okay, so how this electric current is passing up to the bulb, we'll see now. So it has two terminals. The bulb's negative terminal is connected to the battery, is connected to the cell. These two are electric cells. So these two cells are arranged in series connection. One cell's negative terminal is connected to the another cell positive terminal. So this last cell's negative terminal negative terminal is connected to the first electric cell positive terminal. You know, always the positive terminal should connect to the negative, and the negative terminal should have connection with the positive terminal. This already you know this. So the same arrangement is done in an electric torch too. Electric torch is having two electrical cells. So they are connected to each other, and both the cells are also having connection with the bulb. So when it is connected in this way, the electrons are moving like this and the electric current flows up to the bulb. So inside the bulb, just now we discussed, tungsten is present which acts like the filament. So whenever electric current is flowing through the bulb, this filament gets heated up and gives the light, which gets reflected by a reflector and the lens present in this. And the whole body of this torch is arranged inside a plastic body. So this outer blue colored one is plastic body, where inside this the cells, the bulb and the terminals are all are arranged. And it also have a switch which can slide. When it moves front, the switch is in on position and the circuit becomes closed. When the circuit is closed, the bulb glows. And the slide of switch, when it moves back, then the switch is in off condition and the circuit becomes open. When the circuit is open, you know that the bulb will not glow. So this is the inner structure of an electric current, electric torch. How the electrons are moving, how the electric current is produced here, you understood very clearly. Right, children? So the same structure is also given in your textbook. Once again, you read this and all the parts. If you have your own torch, just open and see these all the parts. Clearly you understand and draw this diagram in your notebook. Okay. And now, just now, beginning of our class, I told you, by using this electric circuit, you are going to identify the conductors and insulators, I told you. First, you try to understand the meaning of a conductor. A conductor means any material that allows electric current to pass through them. They are known as conductors, which allow the current to pass through them. They are known as conductors. All the metals, most of the metals like copper, aluminum, steel. This all acts like conductors. Then our body, are we big conductor or the insulator? If we keep our finger in the electric switchboard, do we get electric shock or not? Yes, absolutely, we will get the shock. That means our body is also allowing electric current to pass through. That's why we are also coming under conductors. So conductors means which allow the electric current to pass through them. And like glass, plastic, ceramic, rubber, fabric, cork, wool, wood, paper, these all the materials will not allow the electric current to pass through them. So they are known as insulators. How to understand? How can we say? So in this, instead of the safety pin, you take your eraser and keep it in both the jam pins and observe that whether the bulb glows or not. Definitely the bulb will not glow. Why? Because the eraser is not allowing electrons to flow through it. So that's an insulator. Instead of this safety pin, you keep some copper wire in between both of them, jump pins. Definitely the electric current flows through this copper wire, and so that we can say copper is a good conductor of electricity. In the same way, in place of safety pin, you keep a wooden stick you keep between both the jam pins and find out whether the bulb glows or not. If it is glowing, that's a conductor. If the bulb is not glowing, that's an insulator. So this is one way to find out the conductors and insulators. You can do this activity, very interesting. Collect some materials which I am showing in the picture, and instead of the safety pin, you keep these materials and try to find out whether they pass the electric current through them or not. So in today's class, you learned about electric switches, how the electric switches are playing an important role in electric circuit, you understood. And you also learned the structure of a bulb and an electric torch, the parts present in an electric torch, how they are working, and what's the meaning of conductors and insulators, how to find out the conductor and an insulator. By the activity you can do this, and you can separate both the conductors and insulators mentioned in a tabular column in your notebook, children. And your today's homework is different circuits from your textbook. Identify whether they are open circuits or the closed circuits, whether they are parts of the electric torch, and also write the differences between conductors and insulators. Understood, children? I hope you can enjoy this activity while doing. Before writing the differences between conductors and insulators, before giving the examples, you try to do this activity practically.